Hello, everybody. I'm going to talk a little bit about past, present, and future of object serialization within the Corda platform. First of all, what do we mean by object serialization? Really, I'm referring to how we convert data in Corda to bytes and the reverse process of converting from bytes, deserialization. Primarily, this refers to the transaction data within the Corda platform, the states and the data within those states, and it's the process of converting to and from happens when we obviously pass messages between nodes, messages between nodes and client applications as part of RPC calls, and also in the process of us actually storing the transactions to persistent storage currently in the database. And since day one, we've known that the present solution is not our long-term solution. So our present solution is based on the third-party library Cryo, and obviously, Cryo has many positive aspects to it, which is one of the reasons we chose it in the first place. It's relatively widely used, it's relatively easy to use, and has the capability to serialize most objects within the JVM to a binary format and back again in a fairly flexible and usable form, and is relatively performant. But there are certain downsides that we'd sort of identified very early on that we knew we wanted to correct as we approached Corda 1.0 and a long-term data format for the Corda platform. Some of these issues include not having full control over the binary form, so Cryo doesn't necessarily give us any particular guarantees around forwards compatibility of the binary data format when there are library upgrades, and in particular there's a lack of support for non-JVM platforms, so it makes assumptions about you've got a JVM on either end of a conversation, and for Corda, one of the things we've known for a while is that the .NET desktop apps are fairly prevalent in the banking industry, and we wanted to be able to have .NET clients for at least certainly for RPC to the Corda node, and there's no reason why we should be tying in the ability to read and render the contents of a transaction to JVM platforms. One of the other issues, which is obviously very significant with Cryo, is an inability to get kind of the right mix of flexibility and extensibility of the types of objects that it can serialize, whilst keeping security suitably locked down. Obviously, security is a very high priority for us, and Cryo doesn't give us necessarily the control that we need over the types of objects that can be serialized. Moving on to the requirements of what a replacement for Cryo might look like. One of the things we're very keen on doing is reuse of industry solutions as much as possible. We don't really want to reinvent the wheel and expend too much developer effort when there are tool sets and libraries out there that we could make use of, and industry standards around binary formats. We don't want the sort of configuration and fragility that we've experienced with some of the Cryo implementation around supporting object classes or contract states. And as I previously mentioned, security is a very high priority for us. And given that Corda has a dependency on contract code portability between nodes for verifying the custody chain of the states, we must be able to trust inbound object classes that are not part of the resident Corda app on that node. As I've mentioned, we also want cross-platform support. So right now, we're dependent on the JVM.class file, and we don't want that to be the case going forwards. We do want to maintain our current strategy of kind of code-first design. So right now, contract states are written in a JVM language, be that Java or Kotlin, and by defining classes. We don't want to move to a model where there's a clunky kind of code generation step from some intermediate sort of description language that developers have to learn and that potentially interacts badly with the build processes of IDEs, etc. We want to have the potential to support forwards and backwards compatibility of persisted data. So having the data be, to a certain extent, self-describing so that old formats can be read by new contracts and potentially vice versa. And of course, we want to be able to support kind of object tree deduplication. So things like FPML have a lot of repeated data elements in them, and we don't want to have to create excessively large data structures when there's a lot of repeated data within a data structure. Moving on to the next slide. Where are we now? As part of the preparation for the initial testnet, we're doing some tactical work around the cryo serialization that is in place. That is part, and this will be part of M9. We're kind of doing some customization around the security lockdown of the classes that can be serialized based on a whitelisting process. And we'll be doing some work around the use of annotations on classes to annotate which classes are permitted to be serialized. Part of this is to tackle some of the issues that have been seen out in the wild in terms of exploits and compromises of application servers where people have identified classes that were available in the third-party libraries that were used by some of those application servers and managed to kind of manufacture a payload that could be delivered to an app server and that generates malicious behavior, in particular launching executables, etc., outside of the JVM. So we're looking to kind of cut that off straight away. We're also embedding some information in the binary data streams around what version of the serialization we are using to store any particular object, so that we can always resurrect superseded formats in the future. And one of the current issues that we have is that right now, in order to sort of serialize data successfully between two nodes, you need to have the same set of core apps installed, and we'll be delivering a workaround to that, or a solution to that, as part of M9. In parallel with that, we're designing and prototyping the build out of the strategic replacement for the cryo-based format. We're mapping our requirements onto some standardized wire formats, such as AMQP 1.0 and Avro as our two lead formats. So we're doing some evaluation of those. And in parallel, alongside that, we're evaluating the various third-party libraries that support those those competing solutions to AMQP, and we're trying to identify which of the libraries have the best support. We'll also be developing some code to create classes based on class descriptions for use in areas where we don't trust the provider of a class. So a classic example here in the Corda platform is if we have, we're trying to prove the chain of custody and we need to load a transaction that involves a state from a contract that's embedded in an attachment that isn't part of one of the core apps installed on a particular entity's node. We need to be able to safely deserialize that data structure when we might not trust the classes embedded in the jar file that is the attachment. So we need to be able to essentially sort of spin or weave a an implementation of that class based on a description rather than trusting the bytecode that is in the attachment. We also need to evaluate the impact of any restrictions that some of this is going to introduce on the flexibility of contract states. We're not expecting much or any impact really in terms of capability, but there may be some API impact, in particular the requirement to annotate some classes to say that they're safe to, or intended to be serialized and deserialized. As we head towards version 1.0 and the later stages of testnet, where will we be? Well, the intention is we will have a binary wire format that is based on an industry standard, so something that could be deserialized at the lowest level using third-party libraries that support whatever that industry format turns out to be, whether it's AMQP or Avro. And that binary format will be sufficiently self-describing that a GUI or support tool can deserialize and introspect and render those contract states without having access to the original Java class files that are associated with those states. And obviously, like the rest of Corda, we intend to sort of clearly document all this and how Corda is using the industry format, so other tools can then interoperate cleanly with the Corda node. In addition to that, there would be no need to have a Corda app installed to download and verify a transaction. So we'll have this capability to spin up a class based on the class definition without actually having the original class file. And obviously the existing sandboxing work that we've talked about elsewhere will handle the execution of the verify function and ensure that that is safe and secure. Developers will still just write code to define contract state, so they'll remain in their natural habitat of where they can be nice and productive, and we have access to a large pool of developers. We'll clearly document any restrictions that do get introduced in terms of how classes get written, and if there's any restrictions on particular areas of how those classes are implemented, and there'll be minimal configuration done on the node to support that. And we should be in a situation where an upgraded contract could read a prior version of a contract state without necessarily having the classes available.